right, this example, we're looking to identify the graph that has a range. So we're talking about y values with a restriction at y equals 1. So this is telling us that y cannot be 1. So there should be a horizontal asymptote through y equals 1. And any graph that has a point on the blue curve representing the function, any point that is on that curve that has a y value of 1 would mean that that can't be the correct function graph. So I'm going to look at these each. The first one, part A, you can see these go by 2s, 2, 4, 6, 8, 10. So at y equals 1, that's right about here, and it looks like there is a point that has a y value of positive 1. So that can't be the right option. B, to me, looks like it's probably the correct answer because I've shown a horizontal line through. It's not the best image. I wish we could zoom in on it a little closer. But it does look like as you go towards positive infinity for x, it looks like the y value just veers off and never crosses over y equals 1. And likewise, coming from y equals negative infinity or x approaching negative infinity, it looks like the y values are going to veer off and just hug right underneath y equals 1. So that does look like a good option. So I've chosen that. Y C would not be the right answer. Is, you can see right here, there would be a point with a y value of 1. Also right about here, there would be a point with y equals 1. So those can't be it either. So B would be the best option there. Number 4 says match the rational function with the appropriate description. It says that the x-intercept 3, 0 is on the graph. Well, let's check that out. Let's see that if we input x equals 3, do we get y equals 0? So f of 3 gives us negative 2 over 6, or negative 1 over 3. So that is certainly not 0, so this one doesn't hold true. The vertical asymptote is x equals 5. Now, an asymptote is like an electric fence, where the graph will not cross over it. So that means that if we have a vertical asymptote at x equals 5, so if you can just picture the x-axis and the y-axis, 1, 2, 3, 4, 5, there's going to be an invisible electric fence where the function will not cross it. In other words, x can never be 5. Now, is that true? Let's look at the equation. If I plug in 5, do I get a result that is not real or that is undefined? Well, if I put in 5, I get in the numerator 5 minus 5 is 0. 0 divided by anything else is still 0, and 0 is a real number, so that is not problematic for the numerator. Plugging 5 into the denominator gives me 8, and that is also not a problem. The only time we would have a problem in this scenario is if we had negative 3 for x, because then we would have 0 in the denominator, and that would be undefined. So this is not holding true for our function either. The next one says the vertical asymptote is x equals negative 3. Now that makes sense because we can see we cannot allow x to be negative 3. So actually the vertical asymptote would be through here, not through here. Okay, so then this one seems good. Let's check the last one just to see if that one could be it either. The y-intercept is 0, negative 5. Y-intercept at 0, negative 5. Okay, well, let's check it out. If we plug in x equals 0, do we get y equals -5 from our equation. So we'll do f of 0. Does f of 0 equal -5? Let's see. That would be 0 minus 5 over 0 plus 3, which is -5/3, which is definitely not -5. So this one is not true either. So C was the best answer indeed.